Now that we learn the basic or fundamental of quadratic function, let us draw out one of the quadratic function. This will be easy. For example, say that you were given one quadratic function. The function, it is y equal to negative x squared plus 6x. This can be written in a lot of ways. It can be also written in such a way, negative x squared plus 6x. Note that for quadratic function, the general equation will look like ax squared plus bx plus c. In our case right here, my a, it is -1, right? There's like a 1 hiding here. It is 1. It is not 0. Okay, the a must be at least 1, -1, for it to be a quadratic function. Else, my x squared will disappear. My x squared term will disappear. For my b right here, I have my 6. And then for my c, it is 0. Okay, as you can see, I have nothing. It is plus 0 here. Okay, you need to notice I plus with a 0 term right here. In order for us to draw the uh, graph of this function right here, there's a few steps that we need to do. The first step is we want to know the shape of my quadratic graph. What do I mean? We need to know whether it is a U shape or it is a N shape. Okay. So remember what I told you earlier? For a U shape, we can see a smiley face right here. This is when my A it's equal to positive. Okay, when I have a positive A, I will have a smiley face. Just remember, whenever in your exam result, whenever you got A plus, you are smiling. However, when you have a sad face, when you have a sad emoji, okay, my A, it is negative right here. So in our case, my A, it is a negative one. Therefore, I can conclude my shape of this quadratic function, it is a sad face, right? It concave down. Let me just put it here, right? For the second part, I would like to know the maximum or minimum point. Okay, guys, let's look at this thing. Say that I have a graph. I have, let's say I have this kind of graph. And on another occasion, I might have this smiley concave up graph. Right here, this is what we call my maximum point. And then for this one, this is called a minimum point. In our case, since we are concave down or a sad face, we will have a maximum point. I'm just gonna proceed with my maximum point. For my maximum and minimum point for any quadratic function, it is always given by negative b over 2a. Let's have a look in our function right here. Negative, my b is given by 6 divided by 2, my a is given by -1. I'm just going to substitute all the value inside. So what do I get here? Okay, so I have -6 divided by -2. I'm going to get 3. So what happened here? My minimum point, it is located at 3. What does this 3 mean? I'm just going to put x value. So the general formula, right? General formula for us to find the maximum point or minimum point, it is x equal to negative b over 2a. In this way, you can find your maximum point or minimum point, the x-coordinate of it, right? The x-coordinate of minimum point or maximum point. So in this case, I have my x to be my maximum point since I am concave down. Let me just write this thing down. Maximum point. X coordinate is not sufficient. With x coordinate, I also need my y coordinate for it to be a coordinate, right? I need my x component and my y component. So what can I do? I can take this x. I can say when x equal to 3, what happened to my y? Y is equal to take the original equation, negative x squared plus 6x. And since my y is equal to negative x squared plus 6x, I want to substitute my x into my y equation right here. Square plus 6 multiplied with 3. What I'm going to end up with, I'm going to have negative 9 plus 18. So y equal to 9. So I can say my maximum point, it is 3 and 9. Now this complete my maximum point coordinate. Let's recap. First step, I need to determine whether it is concave down or concave up. Once I know it is a concave down, in this case, I know this must be a maximum point. How do I find my maximum point? First of all, I need to determine the x value. X value of my maximum point or minimum point is given by negative b over 2a. Okay, I got my b from here, the general equation of quadratic function. I got my a right here. So what happened next is I substitute in, and then I'll get my x is equal to 3. That is my maximum point, x coordinate. When I have my x equal to 3, I can use the x value, substitute it back to the original function. Now I have my y. Let me draw you guys something. So what happened here? I know it is a concave down. It is a concave down. Then I know my maximum point, x coordinate, it is 3. When my x is 3, how do I know my y value? I substitute the x equal to 3 into the original equation of the curve right here. When I do that, I can determine my y value. There we go. Great. Next, the third step. After we determine the shape and the maximum point coordinate, the third step, it is to find my roots. You might ask me, what is roots? Roots, it is basically just your x-intercepts. Where is my x-intercepts? We heard about y-intercepts, but then x-intercepts, this is our first time hearing it. X-intercepts, it is the value of this thing right here. When the curve crosses the x-axis, we call it x-intercept. So how do I get my x-intercept? Intercepts. X-intercepts happen when my y is equal to 0. So what do? I take my original equation, which is y equal to negative x squared plus 6x. I will equate it to 0. So what happened here? I'll have 0 equal to negative x squared plus 6x. We need to solve for x. One way to solve it, I can use factorization. So what I can do right here, I can factor out the x. When I factor out the x, I'm left with negative x plus 6. This will give me two solutions. The first one, 0 is equal to x. The second one, as you can see, my 0, it is equal to negative x plus 6. Then I'm gonna get, I will move my 6 over, equal to negative 6. I multiply both sides with negative 1. I will get 6 equal to x, or x equal to 6. Okay, at this, I'm for my first x solution, I'm gonna write x equal to 0. So it turns out my x1 is equal to 0, my x2 is equal to 6. This method can be it can be done using calculator. Okay, if you have every calculator have their own different way of finding this answer. So for this particular model of calculator, you want to press mode, go to number 5 equation, choose for quadratic equation ax squared plus bx plus c equal to 0. So once you are inside, you're gonna just key in all the a, b, and c value. For case, my a is negative 1, my b is 6, my c is 0. Okay, I can get my x1 and x2, right? Okay, 0 and 6. So now, what happened here? It's my curve. It's slowly becoming, I can kind of like guess what does my graph look like right now. It has intercept of 0 and 6. 0 right here, and then 6 right here. And then I know the middle point, right? It is 3, because I know my maximum point. It is 3 and 9. Okay, there we go. Oh, well, I think this is our sketch right there, right? And then for the last part, it is just to find the y-intercept, this point right here. Okay, coincident. The last part is to find the y-intercept. In our case, it is pretty much obvious. Okay, my y-intercept, which is my c, it is equal to 0. Okay, it is pretty clear in our case. But if it is not clear, we will need to find out. Okay, at y-intercept. I'm gonna write my x will always equal to 0. Okay, this is just the nature of it. Okay, whenever my curve crosses my y-axis, my x will be always equal to 0. So when my x is equal to 0, I can substitute, okay, the number x is equal to 0 into my general equation. Y equal to negative squared plus 6 multiplied with 0. My y will be equal to 0. So my y-intercept, it is 0 in this case. with this, there we go. I can draw our final curve. So x-intercept of 0 and 6, maximum point of 3 and 9. There we go. This is my full sketch. Also, you cannot forget to label my y-axis and my x-axis. There we go. Let me recap a bit. In order for you to successfully draw your curve, you need to perform 4 steps. The first one, you want to determine the shape. Second step, you want to find the coordinate of minimum or maximum point. The third step, you want to find the x-intercepts, which is just the roots. Last step, you need to find the y-intercept. That's all for today. If you learned something, please consider liking it and subscribing. Thank you very much. Bye bye. See you guys.